Okay, we can graph a tangent function by thinking about the unit circle. So if I set up a unit circle, and this ordered pair is 1, 0, this ordered pair is 0, 1, this ordered pair is -1, 0, and then 0, -1. And remembering that tangent is opposite over adjacent, the tangent of an angle is the opposite of the angle divided by the adjacent. So that's actually going to be y divided by x. So if I go around the unit circle, I'm going to have y divided by x. So if the tangent of 0, y divided by x, 0 divided by 1 is 0. The tangent at pi over 2 is going to be 0 divided by, or 1 divided by 0, which is undefined. The tangent at pi is going to be 0 divided by -1, which is 0. Down here, it's going to be undefined. So at 3 pi over 2, it's undefined. And then at 1, 0, or at 360, or 2 pi, it's going to be 0 again. So it's going back and forth between undefined, 5 pi over 2, 3 pi, and 0. That doesn't really help us graph it much. So I'm going to actually add something else to it. That every time you're going around in a 45-degree angle, remember that the ratio is going to be √2 over 2 divided by √2 over 2. So every one of these red lines represent tangent having a value of 1. So that's going to come 1 or -1 actually. So that's going to come into play too when I graph it. So a in a tangent function makes the function, if it's positive, it makes it go up from left to right. So if a is positive, it's going to make it go up from left to right. And if a is negative, the tangent function is going to go down from left to right. And the period of a tangent function is not 2 pi over b, it's pi over b. So I'm going to graph the tangent function first by plotting my zeros. So my zeros are at 0, 0, pi 0, 2 pi 0, and then I'm going to keep going to the left, -pi 0, -2 pi 0. And then, where these are undefined, these are going to be our asymptotes. So I'm going to draw vertical lines, because asymptotes are vertical lines for tangent functions at these places. At -pi over 2 and at 3 pi over 2. The period of the tangent function is pi. Okay, so the period is pi in a tangent function. So if you just have y equals tangent of theta or x, the period is pi over b, and b is 1, so that's why it's pi. So between here and here, I'm going to have one cycle of tangent. Right here is going to have one cycle of tangent. So I added these 45-degree angles to show that this would be 1, because this would be √2 over 2 divided by √2 over 2. This would be -1, because this would be -√2 over 2 divided by √2 over 2. So I'm going to add those in as well. So at pi over 4, it's going to be +1, and at -pi over 4, it's going to be -1. So I'm going to keep that going. If each of these cycles is the same, I can draw in these other -1s, 1s, -1, and 1s. So what we have here when I finish drawing it is I have these functions, or this function, like this. So the reason that it has an asymptote is because you can't divide by 0. And tangent is the y divided by x. So whenever the x value is 0, the tangent's undefined. So on this y-axis, the x values are 0. That's where you get it undefined. And so what would happen if you put a 2 out front, let's say you had a was 2. What would happen is it would just increase faster. So this would be a 2, this would be a negative 2. If you had a 3 out front, this would be a 3 and a negative 3 right here to make your tangent. And if the periods change, the periods just closer together or farther apart. So first what you want to do is determine the period, and then determine the asymptote, taking half your period, taking half of the period. It's going to be more complicated than that though. And then what you're going to do after you take half of the period, I'll show you up here. You're going to add the period to the asymptote. So asymptotes are vertical lines. So what you're going to do is if the period is pi, right here, so this one had a period of pi. So if 0 is your x-intercept, you're going to go up half a period. So the first x-intercept is x equals pi over 2. And the next one is found by adding pi. So it's going to be pi over 2 plus pi over and over again. So I'll do some examples down here. The x-intercepts will be halfway between the asymptotes. We're going to divide the period into 4 parts and then plug in other values for x or pi to complete each tangent. So each one of these is called a tangent. Each one of these right here. This is a tangent function and these are called tangents. So we'll try these right here. So the period, remember, is pi over b. So the b is 1/2, so it's pi over 1/2. So the period here is 2 pi. So what I'm going to do is, if my period is 2 pi, in this tangent function, we're not shifting it left or right or anything. So if the period's 2 pi and the 0 happens at 0, that means my asymptotes are going to go right a pi and left pi. So because the a out front is 1 right here, that means that I'm going to go up halfway over between the asymptote and the 0 and go up 1 and then go down 1. So this is going to be one of the tangents. So if I keep that pattern up, if this period is 2 pi, I'm going to go up another 2 pi from pi and then back another one here and draw my x-intercepts and my other 2 points. So this is another tangent, and then this is another tangent. So when defining your or your vertical asymptotes, you want to write it as an equation. So it's going to be x equals, the first vertical asymptote is at half the period, which is at pi. So it's going to be pi, and then I'm going to do plus or minus the period, 2 pi, and then I'm going to write n. Now n is an integer, so, or n is actually I'll put n is an integer, because what that means is it's just going to keep, you can just keep adding 2 pi. So add 2 pi, add 2 pi, add 2 pi, and you're going to get this vertical asymptote. So if n equals 1, you're going to add, you do pi plus 2 pi to get the next vertical asymptote. If n equals 2, you're going to add pi plus 2 pi. So the next vertical asymptote is going to be 5 pi. Same with the intercepts. You kind of want to do the same notation. So the intercept, the first x-intercept is at 0, but then the next x-intercept is the period. So it's 0 plus or minus 2 pi n. So we don't really need that 0. I can just write plus or minus 2 pi n for my intercepts. So let's try another one over here. So the period is going to be 2 pi over b. Oops, sorry. I was doing the other function. So the period is going to be pi over b. Oops. So pi over b. So the period is pi over 2. So if I have an x-intercept of 0 and my period's pi over 2, that means that I need to go up a half of pi over 2, which is at pi over 4. So I'm going to draw, because between here and between these two red vertical lines, this is going to be tight, is going to be pi over 2. I'm just going to draw a couple of these. I'm not going to draw, or a few of these. I'm not going to draw the whole thing. So the x-intercept, or the vertical asymptotes, are going to start at half the period. So the vertical asymptotes are starting at pi over 4. This is pi over 4. So remember, write an equation. So it's going to be x equals pi over 4 plus or minus adding and subtracting the period. So pi over 2n. And that n means it's going to go on infinitely. There are an infinite number of vertical asymptotes. And the x-intercepts start at 0, and they go up by the period pi over 2n. I don't need that 0, so it's plus or minus pi over 2n. And now I'm going to draw in my tangent. So this tangent function is negative. Okay, so this means that it's going to go down from left to right. So and it's not a vertical stretch at all. So I'm going to go back in here and wish this was neater. But, so I'm going to go halfway in between the halfway between the x-intercept and the vertical asymptote. I'm going to make a point, but it's going to be a negative. Okay, it's going to go down. So I'm going to make a point right here and a point right here and draw my tangent. So I'm going to do the same thing over here. I'm going to go halfway between the vertical asymptote and the x-intercept and go up 1. And then I'm going to go halfway between pi over 2 and 3 pi over 2 and go down 1. So I keep going right here. Oops, this should be down here. It's kind of messy, okay, because it's so tight. But those are what the tangents look like. They're negative because this function's negative.